Batteries. You guys like batteries?
Yeah.
I like batteries. I think a lot of us have a battery in our pocket, right? You have a cell phone? You got a battery. My laptop here has a battery. My iPad has a battery. Lots of stuff has batteries. Batteries are electrochemistry in action. Very practical. Really, a battery is just a voltaic cell packaged conveniently to be used as a portable source of electricity. The reactions that are occurring in the battery depend on what type of battery it is. So we're going to talk about a couple different types of batteries. There are dry cell batteries. These are what you think of as your regular household batteries, the batteries you might have in your flashlight. And they're called dry cells because they don't have a lot of water in them. It's more of a paste. So here are the half reactions that occur in a standard dry cell battery. We've got zinc. Zinc is the casing, the outer casing of the battery. That acts as the anode. Oxidation occurs at the anode. And the cathode is a graphite rod. That's a neutral electrode, an inert electrode. And the reaction going on there is manganese 2 oxide reacting to form manganese 3 oxide. So we could write the overall reaction. I don't know why I thought that would be a good idea. So here's plus 2 electrons on the right, plus 2 electrons on the left. Do you want to see me copy that down? No, it's in the book. I'm not going to test you on what these reactions are. The combination of these two half reactions gives a voltage of about 1.5 volts. So if you look at a AA battery, a AAA battery, a C battery, a D battery, what are the voltages on those? 1.5 volts. They're all the same. And how do you get a higher voltage? You string the batteries together in series, and then their voltages add up. Okay? So we've got the graphite rod, and that's in this moist paste containing the manganese oxide and the ammonium chloride. Now, the standard dry cell batteries are not rechargeable. If you run this reaction backwards by forcing current through the battery, you are not guaranteed to remake your original reactants. That's what's required for a battery to be rechargeable. And so that's why they have warnings on some of these batteries that they're not rechargeable and you shouldn't try to recharge them. They will explode sometimes. Alkaline batteries, these are what have become regular. Okay, alkaline batteries, they have the same half reactions, the zinc and the manganese 2 oxide, but it's in a basic medium instead of an acidic medium. Hence the term alkaline batteries. These are basic batteries, literally basic. And again, we could add those two together, but we're not going to. So here we have, again, the zinc anode on the outside and a graphite rod for the cathode. That's the little button part, right? And down here, we've got the terminal being the zinc. And then inside, we've got the manganese 2 oxide in here, but now it's in a potassium hydroxide paste instead of an ammonium chloride paste. So why would we do this? Well, they have a longer working life and a longer shelf life than a regular dry cell. So they work better.
Ammonium chloride is not that stable or something?
I'm not sure the exact reason why they're better, but they are.
Is it?
Well, you know, people are trying to improve batteries because you can make money selling better batteries, right? Better batteries. Like, you know, that would be even better than a better mousetrap. Lead storage batteries. These are car batteries, basically. Car batteries can have 6 electrochemical cells in them that are wired in series. Each cell produces 2 volts, and when you string them together like that, you get a total of 12 volts, which is what your car is designed for. These are, they're called lead acid because they involve lead and acid. So the reduction the oxidation reaction is solid lead reacting with hydrogen sulfate to form lead sulfate, which is insoluble. And the reduction reaction is lead 4 oxide also reacting with hydrogen sulfate to also form lead sulfate. Does that bother you? It's like, what? Doesn't that give you just a little bit of pause? What's the oxidation number on lead in this compound?
4.
Plus 4. And in lead? 0. How about in lead sulfate? Plus 2. So in your car battery, you have the oxidation of lead to lead sulfate and the reduction of lead 4 to lead sulfate, lead 2.
Yeah.
So inside the battery, we've got lead electrodes. PbO2 is not the electrode, but we pack a lead grid with the lead oxide. And then the anode is lead grid packed with really finely divided lead particles. They call it spongy lead. What happens as this battery runs is this lead sulfate, being an insoluble substance, is going to build up and coat the electrodes. When the electrodes are coated with this stuff, they're not going to be able to react with the sulfuric acid anymore. And so the battery will die if it's run too long without being recharged. Because these batteries are not meant to run for long periods of time. They're meant to give enough current and voltage to start your car and then to be recharged. And they can be recharged using an external current from the alternator in your car or from the trickle charger in your garage, or yeah, that's pretty much it. Or lightning, perhaps. Aw. But running these reactions backwards does generate the original materials. Here, the lead solid, this was originally this spongy lead. So the fact that we're regenerating it in little particles is not a problem. If the lead electrode was a solid piece of lead, when we ran the reaction backwards, it would not generate a nice intact piece of solid lead. And so that would be a problem. Any questions? So, this hydrogen sulfate comes from sulfuric acid, having lost one proton. So there's sulfuric acid in your battery. That's why sulfuric acid is sometimes called battery acid. And definitely, if you have one of the types of batteries that you sometimes have to add water to and isn't completely sealed, if that gets knocked over and spilled, you need to take care when you clean that up. Get a big box of baking soda and neutralize the acid before you touch it. Rechargeable batteries. These are great. One kind is a nickel-cadmium, also known as a NiCad battery. And here I gave up on writing out the equations. Because I realized, what am I doing this for? There's an awful lot of them. You could look those up if you need to. So here the anode is solid cadmium. The cadmium is oxidized to cadmium 2 hydroxide. The cathode is this funny-looking guy, NiOOH, and that gets reduced to nickel 2 hydroxide. They're solids, yes. No, this is not an alkaline battery. This is a nickel-cadmium battery. These are the types that are used in a lot of electronic devices. So the overall reaction gives a voltage of 1.3 volts. If you need more volts, you make multiple cells and string them together in series. So just like with the lead-acid battery, we do get solid products that build up on the electrodes, but running current in the opposite direction regenerates the reactants. And so these are rechargeable batteries. The problem is when you're charging the battery, you don't want to go too long. If you keep running current through it and you've regenerated all of your reactants, now you could potentially have some unwanted side reactions that you're driving, and they could damage your battery or even cause it to blow up. And so most chargers have some sort of a sensor in them that detects either a current change or voltage change and stops charging when the battery is fully recharged. Oops, ran out of slides.